Hi guys, this is a video for the Capstone project of IBM Advanced Data Science Specialization. Thanks to Romeo Kinsler and other instructors for putting together 3 wonderful courses and leading us through the Capstone project. For this project, each one of us was required to build an end-to-end data product using 2 of the machine learning models to solve one real business problem. The problem I chose is predicting the return of stocks. It's an interesting topic, and I know it will be extremely hard. I don't expect that using only free data that I can beat those Wall Street professionals. So my goal is to only provide some useful suggestions from the model using the public data. And I will choose only one stock, which is the Loblaw Company Limited, the Canadian grocery store, and to test the idea. I will collect data using free APIs. One part is the data of the stock's price and the volume from both Loblaw and its competitors. Also, I will collect the composite indices of Toronto stock market and the US stock market. I will collect the economical indices, including CPI, BCPI, interest rate, exchange rate, etc. from the Bank of Canada. And also, I will collect the Google Trends data using some of the keywords like stock, Loblaw, grocery stores, these such keywords. So here are the data that I collected. You can see here there are a lot of missing values. That's because in some of the days the stock was not traded, and some of the data are weekly or monthly data. And the earliest data starting from the year 1999, but not all the data start from that time. And we can see from some of the data we have 0 value in price and volume. So for those that we don't have a proper stock price, we choose to remove the data point. And for those weekly and monthly data, we will use the last appropriate value to fill the missing values. So here is the chart of the stock price. You can see that we have data from the year 2004 to the current date. So it covers the whole economic cycle. And if we use the nearest data for tests, we will notice that the test data set will include mostly the positive returns. The stock market is good in the past few years. And this is the 5 days future percentage change, basically the 5 days return. So we can see most of the values are in the narrow range around 0, but there are a few outliers. In some of the days, the 5-day return is even more than 20%. So these are the outliers. And if we can see the correlations between the 5-day percent change and other variables, we can see the correlations are very small values. So we can expect that our model won't be very accurate because the correlation is quite small. And we hope that we can find some useful information from those small correlations. Before we build the model, firstly, we should create the target variables. We don't want to predict the continuous number of 5-day returns. It will be very hard. So let's make it to a discrete value. So I assigned the return label 0 to 4. So using the QCut 5 to change the return value to a return label. And there are 2 ways to do this. One is use QCut to divide it equally. The other is assign 0 and 4 for those outliers, and others in between using 1 to 3. And here's features. So besides basic features, price and volume, we use simple moving average and the relative strength index to create some of the new features. So they represent the historical trends in the current data. Now we have the target and features. Let's try out with the random forest classifier. Here are the codes, and we can see the result here is not very good. So 19% accuracy rate is even lower than random guess. And from the confusion matrix, we can see that the model only gave predictions of 0 and 4. So either it says the return would be very bad or the return is very good. It cannot predict accurately. And if we use the outliers method to build the target, here it is, and the result is here. The accuracy score seems good, but actually not, if you can see the confusion matrix. Now the model only gives predictions of value 2, so it doesn't predict at all. So I try to figure out why my model doesn't work. I think maybe one reason is still too complex. It's hard to predict a level of 5, so I changed it to 2. So now it only have to give predictions of going down or going up, good days or bad day. So it's a binary classification. And 5-day return may be a little too short term, and many of our variables are monthly variable. So I changed the return, the target, to 20 days return. Now we have to rebuild the target variable here, and here's the random forest classifier. Now we have the result. It's more than 57%, so it sounds not bad. Let's look at the confusion matrix. Now, if the model gives a prediction of 1, which means the stock is good, so it's a little bit likely to be good. And if the model gives a prediction of 0, it says the stock price will go down, the return will not be good. And you can see these are useful suggestions because the actual return will be more likely to be bad. So it's not 100% accurate, but it's at least some valuable suggestions you should be aware of. So if we look at the importance of these features given by our model, we can see our ideas are tested. So basically, the Google trend of grocery store is the most important features here, and the Google trend for Loblaws here, and GWL is a related companies. CER is the exchange rate, and BCPI here. So our assumption are these indices are related to the stock price. So it's tested. So maybe next step we should try to improve those data quality. Maybe we should be more creative, try to find other keywords in Google Trends so we can make a better prediction. Now let's try using a deep learning model. Because this is a time series prediction problem, we'll try to use LSTM model to build a neural network. So we need to create features that suit for LSTM. Firstly, we need to have it scaled, and we need to build a 3-dimensional array here to refer to each of the targets. And we start with a simple neural network with 20 cells, job arrays such, and we run it for 30 epochs. The loss function looks like this. The result isn't good enough, but let's try to modify the parameters. Here we started with a more complex model here with 80 cells, and if we run it for more than 100 epochs, we can see the model start to overfit, and we need to simplify this model by increasing the dropout value by reducing the number of cells. So we try out these different parameters here, and this chart is the best in this page. So we keep trying different parameters, and I think this one with 40 cells and dropout rate 0.6 is by far the best. So here it is, but it's still overfitting. So last time I tried to use the early stopping method to try to stop the model here. So here's the result, but it's not good enough. The result didn't beat the random forest model. So that's the result of my models, and I think the idea was tested. We should improve the data quality of Google Trends and other indices, and for future testing, I should schedule the task using the IBM Cloud, so I will get predictions each day in the future, and let's see how it works with real data. And I'm not satisfied with the result of SSTM models. I need more research and try to improve it. Okay, so this is my project, and obviously I need to learn more about machine learning. There's a lot to learn. So thank you for watching, and if you have any ideas of how to improve my model, I will appreciate if you can leave comments here or send me an email. And if you are learning data science, I hope you good luck and enjoy the journey. Bye bye.